Hi, I'm Peter Clift, Professor of Geosciences at Louisiana State University. In earlier videos, we investigated the origins and impacts of the Asian monsoon. We emphasized the role of the high Himalayas and Tibetan Plateau in controlling the climate. However, any continent can generate a monsoon where there is a seasonal contrast between the temperature of the land and the oceans, which forces reorganization of the winds and draws moisture deep into the continental interior. In this video, we're going to look at the North American monsoon and see what causes it and how it affects people. The North American monsoon affects the southwest part of the continent, where it brings in significant amounts of rainfall. The area of maximum summer precipitation is focused in northwest Mexico, in the Sierra Madre Occidental states of Sonora, Chihuahua, Sinaloa and Durango, but also extends north into the southwestern United States, where it especially affects Arizona and New Mexico, although wider areas across the western United States also receive summer rain related to the seasonal reversal of regional wind patterns. Over this region, more than half of the annual precipitation falls between June and September. In contrast, the region to the east has little summer rainfall. Like its bigger Asian twin, the North American monsoon is characterized by a summer season of strong precipitation in what is otherwise an arid region. The monsoon starts in late May to early June in Mexico and in July in the southwestern United States. Onshore winds bring moist air from the warm, tropical eastern Pacific Ocean and the Gulf of California, while the Gulf of Mexico contributes some upper-level moisture. Unlike the Asian monsoon, where rainfall continues for days or even weeks, the North American monsoon is characterized by dry mornings when the air heats up, followed by afternoon and evening thunderstorms, with the cycle repeating the next day. In addition, the North American monsoon has intervals when there is little rain. The monsoon season is marked by violent thunderstorms and flash flooding accompanied by lightning that can be a serious hazard in the arid canyon lands of the region.
Fires are now a more part of our ordinary experience. The predictions that things would get drier and hotter are occurring, and that will continue.
On the other hand, summer rain waters these deserts and reduces the risk of brush or forest fires. As southwestern North America heats up in the spring, a strong low-pressure region forms over northwest Mexico and the southwest United States that draws in moist air from the southwest, especially from warm waters in the Gulf of California. The low-pressure region is blocked to the east by a summer high-pressure system around the Four Corners region and by cold air masses caused by upwelling cold water in the eastern Pacific Ocean along the California coast. This stops the North American monsoon from extending all the way to the Pacific Ocean. The low pressure and rainfall over northwest Mexico and the southwestern United States are less intense than seen in Asia, largely because the Tibetan Plateau and the Himalayas are much higher than the Mexican and Colorado plateaus, especially the Sierra Madre Occidental. Nonetheless, in both areas the rainfall is focused in mountainous regions. The North American monsoon is also subject to feedback, in which rains foster growth of vegetation in the Sierra Madre Occidental, which evaporates from soils and plants to add moisture into the atmosphere. Furthermore, tropical cyclones in the eastern Pacific sometimes add rain as their remnants move inland, causing destructive flash flooding. There have been significant historical variations in the strength of the monsoon season, But unlike in Asia, these do not seem to be tightly coupled to oceanic cycles like El Niño. Because the monsoon is linked to mountainous regions, the North American monsoon is believed to have been active since the late Cretaceous, around 80 million years ago, when the severe orogeny began forming mountains in the region. Climate models predict that the monsoon would have intensified, especially following the younger Laramide deformation and uplift as the interior seaway of North America closed and the continent became drier. The North American monsoon weakened following the last glacial cycle and only intensified after around 8,000 years ago, when the waters of the Gulf of California became warmer and the cold waters of the coastal California current weakened. This resulted in more moisture flowing from the Gulf of Mexico and the Pacific Ocean, and a more widespread monsoon region. After 7,500 years ago, a strong California coastal current pushed the rain back towards the east and into the more restricted area we see now. Climate records derived from analysis of stalagmites in New Mexican caves show that before 4,000 years ago, the climate was drier than today, but became more like the present between 4 and 3,000 years ago. After that time, the climate became cooler and wetter, which allows the Anasazi people to start planting corn and settling in towns. A dry period from 300 to 700 AD was followed by a wet phase that lasted until 900 AD, after which the climate slowly dried again. It was during the wet times that the famous cliff dwellings were established, such as at Mesa Verde and Manitou Springs in Colorado. As the region dried, these cities were abandoned, and the Pueblo cultures moved to lower elevations and thrived near rivers, such as at Chaco Canyon in New Mexico. Climate modeling suggests that future monsoon rainfall in the southwestern US and northwestern Mexico will weaken due to global warming. Most of the precipitation decline is linked to uniform sea surface warming, which stabilizes the atmosphere, resulting in weakening of the convection that brings moist air inland. Because this region is already arid, such models imply a need for long-term planning to offset the harm to water resources in this rapidly growing region. Phoenix, Arizona was the fastest growing big city in the US from 2010 to 2020. I hope you enjoyed learning about the North American monsoon and how it affects and is influenced by the climate, the Pacific Ocean, and the geology of the region. Check out the following references if you'd like to know more about the North American monsoon, and don't forget to look at the earlier videos about the Asian monsoon.